So from the previous part I did replace these transistors here, the old germanium ones with silicon ones, and remember I had loss of gain on one channel. I searched everything and I couldn't find any problem like any shorted capacitor or something like that. Then I did make some research on the internet and YouTube channels and stuff like that to see how preamplifiers work, to have an opinion of what I'm doing. And let me show you what I learned a little bit. So that here is a very typical arrangement of a preamplifier. I mean 1, 2, 3, 4 resistors, 1 transistor, and 1 capacitor that is called bypass capacitor because it bypasses the AC. This is the input capacitor to stop any DC going from the power supply into the input, and this is the output capacitor to stop any DC from going from the power supply to the next level of amplification. So there I learned that this capacitor plays a big role on gain. So if you put it, you get much more gain. I cannot explain right now exactly why, but because I had different gain on one and another channel, I thought that maybe this capacitor was faulty. It wasn't sorted, but I had to check. So these are the capacitors. Let me show you. You see the 50 microfarads, 15 volts. These are the 50 microfarads, 15 volts. These are from both channels, and look at that. I'm holding the phone with one hand and doing everything with the other hand, which is not very easy. On. You see, it doesn't go further. It's monitoring and monitoring and monitoring. That means that this capacitor is not sorted, but it's like an open circuit. It has no capacitance at all. So this capacitor here was acting as if it wasn't there at all. Let us see the capacitor from the other channel and see if that showed anything. Let's go, there we are. So this capacitor did show something. That's why I had more gain on one channel, I guess, but it cannot measure capacitance. So both these capacitors were bad. I replaced them. It's these two capacitors here. Okay, it's these two capacitors. 50 microfarads you cannot find now. You can find 47 microfarads. It's no big deal. I did use this side because I had easy access. From the other side is not easily accessible, and that way I did put some protection tape under them here. But I think this was easier, just to, in case something doesn't work, to be able to take them out again and do stuff. I took it a little bit further, not much, and I replaced all this, no, not all, this capacitor here, and this also, these two capacitors for both channels, the input capacitors, and they are this capacitor here and this capacitor here. The original ones measured much more capacity than 10 microfarads, and also measured very high ESR, internal resistance something, and I think that way is much better. So now let's see what we have. So I powered on the machine. I pressed the two buttons to be on external input. Here I have a microphone there, and look. Hi, 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 hello, 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 hello. So this channel is working. Let me try the other one. Hi, 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 hi. So the other channel is also working. Not to mention that I have nearly no sound. Okay, if I take out the microphone and I put the two volumes to maximum, I get some static noises, but if I touch this, they nearly stop. Or maybe that, I don't know. But generally, I seem to have a good result. So, I'm over with the electronics of the amplifiers here. I did make the oiling and all the normal service on this mechanical part. I won't show it on this video because I did it on a previous video with another machine. Actually, it's the machine lying there. Okay, and as you can see, everything seems to work fine, and also the lifting of the idler for the works also fine. So generally, when I arrange the motor capacitance the capacitance of the motor capacitor that I showed earlier, I think this machine will be in nice condition. So before I proceed to other stuff, I wanna tell some things about motor capacitors. This is a machine, a SONY TC-200, and this is also the same machine. These motors are synchronous motors, so their speed depends on the frequency of the network. But they have two phases. So one phase gets power directly from the motor, the other phase gets power from the power stored in the capacitor to go to the motor, which has a little bit time delay. Normally is in between the two iterations. Okay, that is between two cycles of the power network of the house. Okay. These capacitors for Sony machines, they are about 1 to 1.5 farads. Okay, so this machine here was sold most probably directly in Europe, where the frequency is 50 Hz, and this is how we can see that. You see that this capacitor, this is the motor capacitor, has 3 pins. The center pin is the common, and one pin is for 1.5 farad, and the other pin is here is for 0.5 farad. So you either take from these two for 1.5, from these two for 0.5, or from both these, which is the case here, combined, so you take a sum of 2 farads. Sony did this because they wanted to use the same capacitor for both Europe and USA, because in USA the frequency is 60 Hz. The common rule is that the less hertz you have, the more capacitance you need. Why? Because if you have less hertz, means the second cycle needs a little time more to come. So the capacitor needs to provide the power a little bit later. Hence, the more capacitance. I don't know if you understood this, but generally the rule is less hertz frequency, more capacitance for motor capacitor. So let's go to the other machine. This machine was probably originally sold in the US, and it's configured for 60 Hz, and we can see that because this pin on the other machine is connected to this pin, so that you have two capacitors in parallel and have a combined capacitance of 2 farads. But this machine, normally, if Sony would sell this on Europe, they would take that here and stick one side here and one side here, so that they have combined capacitance of 2 farads. So this machine is working now in Europe with 50 Hz, but the capacitor here, the motor capacitor, is arranged for 60 Hz. So we have to adjust that, and what we only have to do is take one part of this cable and stick it there. Actually, we can measure the capacitance of this capacitor if it's okay, but the important thing is that we configure this capacitor to help motor run at 50 Hz, and for this we need 2 farads and not 1.5 as it is here. This is arranged for 2 farads. You see this cable going from one side to the other to make the 2 parts of the capacitor work in parallel and have a combined capacitance of 2 farads. This is about the motor capacitor of Sony. This is very common in Sony reel-to-reels, that they have a combined capacitor like that. Okay, with 50 Hz, this motor will run a little bit slower than with 60 Hz. So this is arranged normally by using certain sleeves, like, let's see, like this sleeve here. So if you have 50 Hz, you increase a little bit the diameter, like 17%, about 17%. You increase the diameter of this sleeve here, so the tape runs at correct speed with 50 Hz. With 60 Hz, a little bit lower diameter for this sleeve because it runs faster, and you have the correct speed. That's how Sony did it. As I have seen, this machine it looks like the same, the sleeve for this looks like the same, so it's very possible. Let me see. You see? This sleeve and this sleeve, they look the same. I didn't measure them, I will do, but they look the same, which means that somebody once brought this machine to EU, and they replaced this the capstan sleeve, but they didn't change the capacitance of the motor capacitor, because they saw that it worked. It might work, but you have a weaker motor, so I will arrange this. So let's look at the diameters of these two capstan shafts here. So, okay, it's 9.62, 9.65, about 9.6 to 9.7. And the other machine, it's about the same, 9.7. So both these machines are configured for for 50 Hz in terms of motor speed. So I guess the only problem of this one is the capacitance of the motor capacitors. So I arranged the motor capacitor with this cable going from here to the other side, and here is ready to be checked, and let's see. So the motor is actually 2 microfarads, which is how it's supposed to be. 1.5 from one side plus 0.5 from the other side. I will now connect this cable back there so that the motor gets the correct capacitance. Something to keep in mind: when you place this idler back in position, be sure to put that brake here back on this position, because normally when you take it out, it just goes to the other side, and I forgot to put it on the correct side and I had problems. So next time, if anybody messes on this machine, take care to put this on this correct position. So it's time to measure the correct speed of the machine. This speaker is hooked here, and this is measuring the frequency. This should be a recording of 1000 Hz, so let's see what we have. Okay, not completely accurately, but what can you say with these old machines? Okay, so it means, let's see the high speed, which is now supposed to be 2000 Hz. Needs a little help this idler, it's not working very correctly, but anyway, I won't mess with this anymore. For me, this is enough with this. I don't know what I'm gonna do with it, but I will not mess with it anymore. Otherwise, anyway, I have this one which is working pretty good, so this one will stay for parts and whatever else I might want it. It could be a good preamplifier for guitar because of valves and all this stuff, because the preamplifiers are working. So that's it. Bye bye. So now I will demonstrate the result. Machine is on record mode, counter to 0, loyalty free music, and I start. I will now press record. The machine is now recording. Okay, recording stopped. Back. Here we are. So the machine recorded. So it records, it plays back, so I think it's nearly fixed, but I think it's in a very good level. Bye bye.